start the session. Just please let me share the screen. Okay, so could you please confirm me that are you getting my screen and my voice clearly? Okay. Okay, and now let's start the session. And at any point of time, if you think that I'm going too fast or I'm speaking too fast, you may interrupt me, and you if you have any kind of the doubt, so anytime you just unmute yourself and you may interrupt me and you may ask any question, whatever okay, so just a minute, let me record the session. Just okay, so let us start. So is 227. Basically, this is a course about cloud computing and Internet of Things. So let us proceed here. This on your screen. So this is a block which have been provided by your university, or you might have downloaded from the eGyan portal, etc. So let us proceed here. So this course basically discussing this course having two section here. The one particular section basically discuss about the cloud computing, and the another section is your the first two block basically devoted to the cloud computing, and the next two block of your course is devoted to the Internet of Things. So this is the scenario here. Now let us start with the unit 1, which basically discuss about the basic of the cloud computing. So moving forward, so you can see here that in the block 1 basically cover the introductory topic of the cloud computing and their service models, etc. Whereas the block 2 covers the resource pooling, etc. What is the resource pooling? We will come during the discussion of the block 2. And in the next two block, the block 3 and the block 4 basically covers the fundamental of the IoT and the some advanced topic of the Internet of Things, which is one of the most popular topic nowadays. So let us proceed for the unit 1. So block 1 having three basically units here. So unit 1 basically discuss about the cloud computing introduction. The unit 2 discuss about the cloud deployment models, and the unit 3 basically discuss about the resource virtualization. So let us start with the unit 1. Okay, so this is your unit 1. So the first unit basically discuss about the differences and the comparison with the traditional computing. So traditional or the conventional computing, the model of the traditional computing or the conventional computing is just whatever the computer or the computing devices we basically use for our personal purpose. So in the traditional computing, we have In the traditional computing, we have some set of hardware and the software, some set of the hardware and the software installed on our system. So whatever the laptop or the computers basically you are using, there we have pre-installed some software or the hardware, and we are basically using our basically we are using the software and the hardware, whatever the installed software and the hardware we have. So we have some limitation here. If you wish to do some particular task, so you must need a software related to the particular task. Suppose that if you wish to go for database programming, so you must have a database software as well as the programming software. So both will be installed on your computer. That is the one of the limitation of the traditional computing. So similarly, so traditional computing, for the traditional computing, we must require on-premises infrastructure, on-premises infrastructure. So whatever the laptop or the computers you may have, you just need that set of hardware in your premises, in your control. Similarly, the another limitation of the traditional computing is the fixed capacity. You have a fixed capacity. You cannot go beyond the capacity of your computers. So whatever the computational power you may have given, you have to stick with that computational power. You cannot simply give a larger task which by your system. If you are providing the larger task which cannot support by your system, that particular task either it may not functioning. So that is the another limitation of the traditional computing. Similarly, the limited accessibility. You have your own personal computer, so you are using that personal computer. If someone else wish to use your computer, then you have to provide the accessibility you have to that is the one of the another is a capital in expenditure, purchasing of the hardware or the software, etc. So these are the some limitation of the traditional computing. Similarly, the responsibility of the security, etc., are the limitation of the traditional computing. So if I wish to use some kind of the remote information, suppose that suppose that nowadays you are using your social media account, like you are using your Gmail or the mail services, or you are using the Facebook, or you are using the Twitters, etc. So in that case, what is happening? Whatever the information or whatever the comments or whatever the images I am sharing with my social media partners or the social media followers, that particular images are being saved somewhere else in the cloud, somewhere else in the some other system. So when whatever you are in your computer, that is where it is located. As a user, we are the user. Whenever we are we wish to mail, I wish to check my mail, then the user must need to connect with the internet, and that internet is basically so you are getting the internet services from the enterprise or whatever the internet service provider you may have. So you are getting your internet, and by that internet you are connecting with the data center. You are connecting with the data center. As data center having data center is a kind of infrastructure, remote infrastructure, which having the larger capacity hardwares and the softwares, like the larger capacity hard disks are there, larger computational computers are there. So they are maintaining your credential, they are maintaining your information. So whenever you are making some comments or you are uploading some kind of the images, that is basically available in your data center. And whenever you wish to access, this information come from the data center your system. So this infrastructure, the data center infrastructure, is a is an example of the cloud computing. So let us discuss some more here. So if we see the history and the evolution of the cloud computing, so the you can see here that the history of the cloud computing has been started during the year of the 1960s. So the metros are kind of client-server computers where the informations are not available on the client. Whatever the information. So in the case of the client-server computing or the mainframe computing, what is the concept is that we have a one server and we have a various client computers which is directly connected with the server. So we may have a various kind of the client computers. So whenever any client computers update any information or wish to retrieve any information, the client always give the instruction to the server. Server store the information and the server reply go to the client. So if the client did some query, so the information is the server. Now when the client 2 wish to access that information, the server reply with it. So you can see here that our informations are basically stored somewhere in the server, and any client wish to access the particular information. If the client having the access permission, the access privilege, that client can access the information directly from the server. So this is the basic startup concept of the cloud computing. So you can see here that client may not need to store the information locally. It is the informations are being stored in the some central location. So during the 60s, we have a central mainframe concept, we have a time sharing concept during the 1950s to the 1960s. So the concept of the multi-programming, concept of the time sharing, concept of the multitaskings were in the 60s. At the same time, during the 1969s, we have another concept of the Advanced Research Project Agency Network, ARPANET network. Probably in the paper of the data communication, data communication and the network paper, you may have heard about the ARPANET. What is the ARPANET? How the computer network evolved, and what is the role of the ARPANET? Later on, it is known as the ARPANET. So it's basically facilities. This basically discuss about the development of the computer networks and their infrastructures. Similarly, in the 70s, we have a concept of the virtual machine. With the advancement of the Java and the another programming languages and the technology, we came with the concept of the virtual machine. A virtual machine concept where may not reflect you some another kind of the architecture, and the underlying architecture may have some another configuration. So just like a Java, why the Java become the platform independent? Because the Java program directly run on the direct like the C programs, they are running directly on the hardwares, and that's why the C program is a platform dependent language. So whatever the program you have run on one particular computer architecture, so if you wish to run the same program to the another computer architecture, probably it may not execute in the case of the C programming. Now, can be a 16-bit architecture, it might be a 8-bit architecture that doesn't affect the Java program, and it can execute at any kind of the architecture due to the availability of the concept of the virtual machine. In the case of virtual, so how the virtual machine basically execute and how the virtual machine basically read the hardware, that is the beyond the scope of this discussion. But in the later on, we may have some discussion of the virtual machine. So in the 1970s, we came with the concept of the virtual machine, and now with the concept of the virtual machine, it is not necessary that everyone must have a high configuration hardware. So with the help of the virtual machine, if you have a low capacity of the hardware in your system, you may execute the high capacity software as well. So in the 1780s, various companies like Apple, Microsoft, IBM developed and enhanced this concept, the virtual machine concept, and the concept of the cloud environment now started up. So in the 1999, Salesforce, kind of the e-commerce site, so Salesforce made a history by offering the first online application. First, like that, for an you are getting the Google Google Excel files you are getting. So what is happening in the Google Docs offer MS Word like a kind of the software, and we can save our information in the Google Docs, and that can be accessible to from anywhere in the world. So that is the concept. This kind of the concept was designed by the Salesforce for the particular business application. So you do not need to install MS Word on your system. MS Office, it is not required that you have to install the MS Word on your system in order to access the Google Docs. So in the Google Docs, what we are doing, we are just logging to our Google Drive, we are starting the Google Docs, and we are starting the typing and similar facilities, whatever the facilities available in the MS Word. Most of the facilities, most of the options we are getting, features we are getting in our Google Docs. So for the case of the Google Docs, you do not need to install the Google Doc kind of the software on your system. You are directly accessing. That is the one of the great example of the cloud computing. Means the software is available for your use without installing the software on your system. So this kind of the concept was developed by the Salesforce during the 1999 for the some kind of the business applications. And now we are moving forward from the traditional computing. So you can see it. So this is the timeline of the development of the cloud computing. So the 1950s, John McCarthy introduced the mainframe system, where the concept of the time sharing and the time multitasking, etc., has been started. In the 1969, we have came with the concept of the ARPANET, which having a major role in the computer networks. Means two systems can communicate with each other. So in during the 70s, we came with the concept of the virtualization softwares, VMware, or the virtual machine kind of the concepts we came. And in the 1997, by the Professor Ramnath, we have a concept of the cloud computing. So cloud computing basically deals with the availability of the software and the hardware remotely, and you can access the hardware and the software remotely. You do not need to install the hardware and the software in your system to access uh, the hardware and the software, the high configuration hardware and the software. If you wish to access the high configuration hardware or the software, so you do not need to purchase. You require a kind of a device which can connect with the service provider, and you can access their services from remotely. So in the 1999, the first cloud computing system was introduced by the Professor Ramnath, and hardwares. So we have made a virtualization hardware for every kind of the hardware, starting from the core devices, core CPU, to the storage devices to the computing devices to the memory devices, everywhere we have expanded all kind of the all these kind of the services are now being provided now being provided. So so uh, in between of the computer network and the cloud computing, we have another kind of the concept, that is the distributed computation. So in the mainframe system, we have a client server concept where all the informations are available with the server. Any client can hook up with the server. If the client have their permission, their privilege, then the client can access the information from the server. That is the concept of the client server computing. Now, everything is available with the server, the centralized server. So this is the concept of the mainframe. Now suppose that due to the any reason, if the server gets down, if the server gets corrupted or the down, then all other clients which are active still cannot access any information. Got down, shut down, shut down, or so due to the any reason, this server is not working. So all the associated clients are there that cannot access the server. So with the mainframe system. So we developed another concept, that is the distributed computing. Now all the information should not be held by the server. We are making a set of the block, the services block, that are available with the more than one system. So that kind of the concept developed, and that became the distributed computing. So in the distributed computing, a single task is spread across the multiple machine in a different location. It may be in the different part of the world. So the central concept, all the information must be available on the central location, is now distributed among the multiple locations, distributed among the multiple system. The concept of the distributed computing has been started. It having a lot of flexibilities, resource sharing, scalability, cost flexibility. These are the flexibilities available with the distributed system. So, so user of the distributed computing can access the additional functionalities available for the purchases. If you wish to go for the some additional kind of the services, then you can directly purchase the services from the particular service provider, and you can access. Just like that Google Docs we are using, we have given some kind of the 15 GB limitation with the Google Drive, so you can use up to the 15 GB free of cost. As soon as the 15 GB is going to complete, you need to expand the space, then you have to pay something. So it means that what? It means that you are paying for the some kind of the services. So that concept was evolved in the case of the distributed computing. Just about the mainframe systems, you can see here that the mainframe systems you can go easily. Now, the another concept was evolved, that is the cluster computing. So in the case of the cluster computing, we have a interconnected computers within a network to operate collectively as a unified entity. So each computer integrated into this network term as node. So every node having their own set of capabilities. In the case of the mainframe system, all the clients are should be identical. So if the client one having some kind of the infrastructure, that should be identical to the client two, that should be identical to the client three. So all the systems are the homogeneous system. Now in the case of the cluster computing, we have a heterogeneous system. So heterogeneous system, so in the equipment of the link computers, tightly interconnection should be there, tight interconnection should be there. There should not be any kind of the bottleneck in the connecting of the systems. Otherwise your systems may operate slowly. So every computer share the identical home directives, etc. That is the concept in the case of the cluster computing. Another concept evolved, that is the grid computing. So grid computing, this concept was came in during the 1990s. So it extends as a computing framework that consolidates computing resources spanning diverse geographical location to accomplish the shared objective. So grid computing is a kind of the concept where the computers are allocated in the different geographical location, and they are sharing their information. So if if I have some information, if my computer having some information, and my computer is a part of the grid computing, and someone else in the another part of the world wish to access this information, the shared information, then they can access my information. So this concept was evolved with the concept of the grid computing. In the mainframe, we have a difference. In a distributed computing, we have a different scenario. In the case of the cluster computing, again we have a different scenario. Whereas in the case of the grid computing, we have some shared object concept. So by amalgamating and the granting access to the unused resources from the multiple computers, grid computing facilitate the execution of the singular task. So now the grid computing tackle the extensive operation or the address intricate challenges, etc. So these challenges were taken care by the grid computing. Now there is the concept of the virtualization occur. So virtualization means suppose that you need to work with a software which requires some high configuration of the hardware. That particular configuration of the hardware may not be available with you. Suppose that suppose that you have a mathematics multiplication or the Java language, whatever the language you may be, or the matrices multiplication program you have written, and suppose that the size of the matrices are 1000 by 1000, or maybe 10,000 by the 10,000. Size of the matrix A is 10,000 by 10,000, and the size of the matrix B is also 10,000 by the 10,000. And now you are going to multiply this one with your simple programming. What will happen? It may take hours of the time or the many days to execute this much size of the matrix multiplication on your single system. So that systems, so the it need to continuously compute lot of things. So your systems may take uh, multiple hours or the multiple days to compute this kind of the matrices. So it is not obvious to execute on my system. Or suppose that I have written a program which may require a supercomputing power. I have written a program for the supercomputer. So, I have a supercomputer course in my syllabus, and I have written a program for the supercomputer, and now I wish to execute that program on the supercomputer. So what will happen in this case? Either I need to go for the purchasing of the supercomputer, or I may need to rent my friend supercomputer. Both of the cases are not easy to find. Either you may have your own supercomputer, or you must have idea about that which friends may have the supercomputer. Suppose that both of the cases are unavailable for your location. Then what is the next? You may approach to the some companies, they may have a supercomputer. So what will do? Definitely you will ask their permission to execute your program on their supercomputer. So what they may charge? Either they may allow you, or they may give the permission to execute your program on their supercomputer by charging some amount from you. Suppose that it may be $1,000 for the half an hour or the 1 hour time. So you have to pay the $1,000, and then you can use their supercomputer for the half an hour. And within the half an hour, you may execute your program. So this is a concept of the cloud computing, and that concept can be the virtualization. So virtualization is basically what? Virtualization may be of anything. It may be of the operating system, it may be of your hardware, it may be of your software. So virtualization means what? The virtual underlying hardwares may not be capable of doing the particular task. Suppose that you wish to execute a program which requires 64 bit of the architecture. which requires 64-bit architecture machine. You only have a 32-bit architecture machine. Your computers or your systems only support the 32-bit architecture program, but you need to execute a 64-bit architecture some program on your system. So what will happen in this case? You cannot directly run the 64-bit architecture program. The program requires the 64-bit architecture on the system having only the 32-bit architecture microprocessor. It cannot execute. So alternatively, what I may do? I may use the virtualization software, and that particular virtualization software will allow me to execute 64-bit architectural program on my 32-bit architecture machine. It is possible with the virtualization software. So virtualization means it will hide the so this is your program, this is your program, this is your hardware. So the virtual machine will come in between of your program and your hardware, and this particular virtual machine will hide the underlying architectural details with the program. So whatever the program requires the architecture, this virtual machine will give a snap to the program that the program will always realize that I am running on the 64-bit architecture machine, even the underlying architecture machine having the 32-bit architecture only. That is the concept of the virtualization. So this is being handled by the set of hardwares or the softwares, mostly the softwares. So So with the advancement of the Web 2.0, Web 2.0 means the dynamic websites, dynamic web pages. With the advancement of the Web 2.0, now it is easy to access uh, the virtualization concept or the virtual machine concept or the cloud compute concept. So cloud computing is a kind of the service-oriented architecture. Service-oriented architecture means whatever the services you wish to take, you just paying for the particular service or using the particular, you can use the service and you can use their particular services. So so at the same time, the some utility computing. So it refers the service model in the cloud computing that offers the client access to the computing resources on demand. Suppose that you only having the 8 GB of the RAM in your system, and you require a 16 GB of the RAM in order to execute your program. So obviously, or suppose that so obviously that particular program will not execute on your device. So what you may do, you may search on the internet who are going to provide a 16 GB architecture for you. So suppose that you have paid some amount. You have made a mutual understanding and you have paid some amount to use their computer for the 16 GB memory. Now during the execution of the program, the 16 GB memory the 16 GB memory has been exhausted, and immediately you required 16 GB more memory. Immediately you required during the execution of the program, the 16 GB memory is exhausted and you need more 16 GB space. Then then definitely you have to stop the program. You have to contact with the service provider for the extra 16 GB. That is the problem with the traditional computing. But in the case of the cloud computing, in the case of the utility computing, on demand requests you may generate. As soon as you are, as soon as you are watching that the 12 GB from the 16 GB already has been occupied. The 12 in the my program has reached to the 12 GB. Now it is executing and it is reaching to the 14 GB, 15 GB. So before reaching to the 16 GB, I may reach on demand to increase my memory size so that my program should not be interrupted. It may execute. It may execute without interruption, without that is the our main objective. So you may increase or the decrease the hardware requirement or the kind of the software requirement or the any kind of the requirement during the execution of the program. So on demand resource etc. That became the concept of the utility computing. So on-demand resources pay per use model. Whatever the models whatever models you are using, you are paid for the software cost. You suppose that you have used only for the 15 minutes, so you have to pay only for the 15 minutes charges. You do not need to pay for the 1 hour charges. So that kind of the fees are applicable. Scalability means one execution, so you may increase the hardware or you may decrease the hardware as well. Suppose that you have purchased a 16 GB RAM hardwares, and during the execution of the program, you have seen that your program doesn't require more than 4 GB of the space. So it has executed for the long hours, but it doesn't expanding from the 4 GB. It is under the 4 GB only. So why I should pay for the extra 12 GB? So I may request the service provider to reduce this one, and accordingly my charges would be reduced. Similarly, the resource pooling, you can demand the extra resources as well, each for the access and the management, service variety, business benefit, etc., reliability and the availability, etc. These are the basic terminologies with the utility computing. So overall, the utility computing revolutionizes the way the computing resources. So now you do not need to procure the hardware or the software in order to use the softwares. So you can directly purchase a service hours from the service provider, and you can use the hardware and the software as well. So now come to the part of the cluster computing and the grid computing. So cluster computing involves interconnected computers working together as a unified system within a confined geographical area. Whereas in the case of the grid computing, extend this concept further by interconnecting geographically displaced and the heterogeneous resources. In the case of the cluster computing, all the computers in the cluster computing is working with a homogeneous architectural concept, whereas the grid computing works with the heterogeneous resources, heterogeneous computing resources. So that basically allow us for the sharing of the computing power, storage, and the application across the different administrative domain. In the case of the cluster computers, every computers having the the cluster computing is basically a homogeneous architecture. So in the case of the homogeneous architecture, all the system must be of same configuration. So suppose that systems require more a particular program require more hardware space or the more storage space. So you need to expand the storage space to the all of the system in the case of the cluster computing. Whereas in the case of the grid computing, it may have the heterogeneous architecture. So one system may have a small storage area, other may have a large storage area, etc. So similarly with the computational power, similarly with the another things. So you can see here that the difference between the cluster computer, grid computing, and the cloud computing. So if we see the characteristics, so cluster computer basically work with a tightly coupled system, single system image, centralized job management, and the scheduling systems. So in the case of the cluster computer, we have seen the computers must be tightly connected. Tightly connected means all the computers should be apart in a one particular geographical location. It may be spreaded with a very limited distance between the system. So a concept of the centralized job management, etc., are the part of the cluster computing. Whereas in the case of the grid computers, it is loosely coupled. Loosely coupled means it should not be in a one particular geographical location. It may be in a different geographical. So it is loosely coupled, decentralized, diversity, and the dynamism, distributed job managements, etc., are the main features of the grid computing. Whereas in the case of the cloud computing, it is a dynamic computing infrastructure. In the case of the grid computing, whatever the resources are available in the system, they are basically available with the starting of the before execution of the system. Whereas in the case of the cloud computing, we may enhance the we may include the extra hardware and the resources depend upon the on demand resource on demand resources, etc. So we have a flexibility, we have a scalability and the flexibility with the cloud computing, which is not feasible with the cluster computer. So that dynamically we allocate the resources. So dynamically we allocate the resources. So self-service use model minimally or the self-managed platforms, etc. Consumption based billing. Whatever the you have consumed, whatever the resources or whatever the time you have consumed, you are paying for that much amount of time. Now, if we talk about the physical structure, the difference between the cluster grid and the cloud computing based on the physical structure. So you can see here that in the cluster computer, a bunch of similar or identical computers are hooked up. So homogeneous concept is associated with the cluster computer. Identical systems must be there, and also in the same physical location, in the same so identical systems with the same physical location and directly connected with the each other with a very high speed interconnection network. So this is the cluster computer. So all should be identical. All the configurations, all the computers should be identical in terms of their configuration. They are tightly connected with each other. Means they are connected with a high capacity interconnection network, and they must be in the same geographical location. In the same geographical location. So this kind of the computers are basically used in terms of connection of the different kind of the servers. So whatever the if the suppose that Google is maintaining 10 number of the server, so all servers are interconnected with each other because they are sharing the information. So suppose that Google having one particular server for the images, one particular server for the YouTube, one particular server for the Gmail services, and one particular server for the some computational services. So all these servers need to communicate with each other very frequently because the consumers may demand anything. Someone is searching for the image, someone is searching for the calculator, someone is searching for the another kind of the services. So all these servers need to connect with each other, communicate with each other. So that can be feasible with the help of the cluster computer. If we go with the cloud computing, then we have a lot of delays. So that's why there we will use the cluster computer. So whatever the cluster computers, grid computer, or the cloud computers we have, that is not this is not true that now we have a cloud computers, so there is no use of the cluster computer. We can ignore the cluster computer. That is not a scenario. All these computing having their own advantage and the disadvantage based on the some criteria. So cluster computer is not obsolete, it is still we are using. So in the case of the grid computing, the computers don't have to be in a same physical location and can be operated independently as far as the computers are concerned, each computer on the grid computer. So as we have discussed that the grid computers do not require the identical systems. Also, the computers should not be placed in a same geographical location. It may be in a different geographical locations as well. Just like that, for an example, suppose that Coca-Cola company having their offices in a different part of the world. So the Coca-Cola company may have a one particular dedicated software, and that software must be used by the all their offices in the different part of the world. So that will be the example of the grid computing. Whereas in the terms of the cloud computing, the computers need not to be in the same physical location, and it is also not required that all the system must use one particular software or the identical software. So cloud computing may provide you any kind of the services based on the some kind of the payment on the some on payment basis, etc. So that is the cloud computing. Now, if we talk the hardware level differences between the cluster grid and the cloud, so you can see that in the case of the cluster computer, all have the same hardware and operating system. As we have discussed, that it is a kind of the identical system. So, in the case of the identical system, must require all the operating system and the hardware should be same. Whereas in the case of the grid computers, in the case of the grid computers, some systems may have their own operating system, some system may have their own operating system. So suppose that my system is working with the Linux, another one system is working with the Apple iOS, another one system is working with the Windows operating system, but the information sharing are same. It may have in the different kind of the different kind of the architecture or different kind of the operating system, but their information communications are same. So that is the grid computing. So a part of the grid can run different operating system and having may have the different hardware. They may have a same hardware or they may not. They may have a different hardware as well. Whereas in the case of the cloud computing, the memory, storage device, and the network communication managed by the operating system of the basic physical cloud unit. So cloud unit having their own set of hardware and the softwares on set of operating system. So whenever I am requesting for the Google Docs, so Google server is allowing to access the Google Docs, and this may have a different kind of the architecture. It might be possible that Google server is using their own developed operating system. They might not use the Linux or the Windows operating system. They may have developed their own set of operating system. But working with the Windows operating system, where the Google working with their still the communications are going on in between of us. That is the basic idea behind the cloud computing. So open source software such as Linux support the basic physical unit management in the case of the cloud computing. If we talk about the resources, so in the case of the cluster computer, whole system behaves like a single system view because that is the identical systems required. So all the systems behave like a single system view. Whereas in the case of the grid computing, every node is autonomous. That is, every node having their own resource manager and behaves like a independent entity. So when I need, in the case of the grid computing, when my systems need to transfer some information to the another system, then only it may connect with the another system and it may transfer the information. The rest of the part, my system will do their own on their own work. And whenever it is required to send the information or someone has asked some information, then only a communication will be set up. That is the case of the grid computing. Whereas in the case of the cloud computing, every node act as an independent entity and every node can act as per the demand. Now come to the applications. So you can see here that in the case of the cluster computer, the applications areas are those kind of the area where they have to do the all the systems have to do some identical work, like educational resource or the commercial sectors or the industrial or the medical research. So all the medical research organizations may connect with the cluster computer and they all are doing the same kind of the task always. Whereas in the case of the grid computing, predictive modeling and the simulation engineering required energy resources exploration or the military or the basic research visualizations, etc. Means the some part of the research organization doing the work on the climate change, some another is working with the medical research, some another one is working with the engineering, etc. All are the part of the grid computing. Whereas in the case of the cloud computing, it is in the different geographical location, and anyone can ask any example so that is located and high it with the low latency high bandwidth interconnection required for the cluster computer, whereas in the case of the grid computing, mostly internet is being used as a bandwidth interconnection. Just a minute only. Okay, so we are talking about the networking. So in the case of the cluster computers, we need a dedicated high-end networking. So a separate networking is required in of the cloud. In the case of the grid computing, it can be accessible through the internet. Similarly, in the case of the cloud computing, dedicated high-end with the low latency, high bandwidth interconnections are sufficient. Mostly the internet can be accessible. Internet is uh, internet is enough for the cloud computing. If you need high power communication, then you may go for the dedicated networking sector. Scalability. So size of the scalability is the 100 in the case of the cluster computers. In the case of the grid computers, it may be 1000, and in the case of the cloud computing, it may be 100 to the 1000 computers can be interconnected with each other. So characteristics. So now it is clear about the cloud computing. So in the nutshell, we can see here that the cloud computing is a kind of the computing where we can demand any kind of the resources from the cloud service provider without having that kind of the hardware, supportive hardware, or the software on my system. My system just only work as a gateway to the service provider. I just need to make a connection with them. After the other the computing will be taken care by the cloud service provider. So characteristic of the cloud computing involves on-demand self-services. On-demand means you can provision for the computing resources. You may ask for the computing resources or the storage resources or the processing power without requiring any human intervention from the service provider. So on demand self services. So your program is running on, and you have calculated that in order to execute, in order to complete the program, you need 10 GB more space. So on demand self service, you just pay for the 10 GB, and you are getting the 10 GB extra services. Broad network access. So its support, it can be accessible from any kind of the devices like your laptop, smartphones, tablets, ubiquitous access of the resources, applications, etc. So you just need a kind of the device which may connect with the cloud service provider. Everything else is looking by them. Resource pooling means dynamically allocation and the reallocation of the resources can be done by the computer. Rapid elasticity means rapidly you may go for the any amount of the increasing or the decreasing of the uh, hardware or the software or whatever you call. If you want for the resource that is rapid elastic the 10 unit of the resource, and immediately after the sometimes you are suddenly required, you suddenly required 100 units of the same hardware or the software that is going to be supported. Measured services. So pay per use model is there. So whatever the number of the units, whatever the number of the resources you have used, or whatever amount of time you have used, you are going to pay for the particular time. Similarly, the service models, it may offer any kind of the service like support service of the supercomputers. So execute your programs, you have to search on the internet who are the service providers providing the services. So you are paying for the you suppose that you require for the half an hour. So you are paying for the half an hour, and they may provide you the services for the particular time. the supercomputing base of the infrastructure as a service. Similarly, the platform as a service, software as a service, platform as a service, it required suppose that RAM, you are uh, or the some kind of the open source software, and curiously you are designing a program or the app which should be run on the Apple software for the iOS operating system. So what you have to do, you have to purchase the iOS software, or you have to purchase the machine which support the iOS software, then only you are able to design the program. Otherwise you may design the program but you cannot see what is the output of the program. You require the iOS software devices. Alternative and that iOS software devices are coming too much costly. So what you may do, you may ask the service provider which is providing this kind of the service, and you just have to pay that. Okay, I just want to use your system for the half an hour. So they may charge for the half an hour, and you are free to now use your program within that particular amount of time. That is platform as a services. Similarly, software as a services, just like that, Google Docs are the one of the I don't have any kind of software like MS Word or the Star of Secretary. I don't have any kind of software which is providing the same kind of the word processing. I just want to type immediately to design a program I may log in. I may immediately example of the software as a service. So Google Docs provide us some kind of the free services, whereas if you go beyond the limitation of the Google Docs, then you have to pay for that. Similarly, the deployment models, so cloud can be deployed at different ways, like a public cloud, private cloud, and the hybrid cloud. We will come on that one, these terminologies: public cloud, private cloud, and the hybrid cloud. For the time being, public cloud means it is available to anyone. Private cloud, it is accessible to the some set of the organization. Hybrid cloud means the mixing of the public cloud and the private cloud. We will come the detailing of public cloud, private cloud, and the hybrid cloud later on the discussion. So benefit of the cloud computing. So now you can easily guess that what are the benefit of the cloud computing, like accessibility anywhere, anytime. So uh, suppose that I'm a I'm a very enthusiasm for the computing. For the computer programming, and so I have designed lot of program in my system. My friend also similarly, my wife or my friend is also using the laptop, but mostly my friend is using the social media like your Facebook, Twitter, etc. So I'm using my laptop for storing my program as well as my project report as well as accessing to the social media site, whereas my friend is using their laptop or their devices only to access the social media site. Now after few days, after a few days, suppose that someone has stolen my computer, my laptop, as well as my friend laptop. Someone has stolen, or suppose that due to the accidental crash, I'm not able to access my laptop. Similarly, my friend also not able to access their laptop, or suppose that stolen. What will happen? There is any botheration to my friend? Yes, both of us are very worried about the hardware. So hardware cost is negligible. Whereas my friend can easily go to the shop and he may purchase. They may purchase a laptop or the computer, new laptop, and this is agent with my if I go to the all the project. If I have not made a backup, then I have lost my all the projects and the programs. That is one of the great disadvantage with the standalone system. So standalone system means I'm not using the cloud services. My friend who are using services, so you don't bother about the hardwares. Hardware can be managed, whereas the information stores are there. That is the cost, and my friend can easily access that. So flexibility of the accessibility anywhere in office is there information. The social media information from anywhere anytime. Whereas in the case of the cloud computing services, I don't need to provide their information, the social media information from anywhere anytime. Whereas in order to access my saved data on Windows and the sources for which you require to work on. Whereas in the case of the cloud computing services, I don't need to uh, procure the hardware or the software. That hardware and the software should not be part of my system. It can be accessible from anywhere. So it is, and as well as I am paying for the amount of time to which I'm using the particular hardware or the software. So definitely dependency is being reduced here. Similarly, the centralized data security, my data, just like my friend information, my friend data, the social media information, the side security and the privacy of the data. So Facebook must have to maintain the security and the privacy of the data. So centralized data security is one of the performance, and using the input output operation per second means if you are suppose that you are accessing the information very frequently, so the service provider, the social media service provider may provide you the high speed of the data access services for you. Similarly, the Swift application deployment. So application deployment without need of any additional hardware or the software, you just need to install the application and the deployment. Access of the data, so you can immediately make any kind of the decision making or the predictive analysis, or you can see the historical in data information, because your data is available in front of you. So you can easily by the help of any kind of the application, you can easily analyze of analyze the data. Whereas in the case of in the case of the we have to go for the purchasing of the specialized software for the predictive analysis or the decision making. So that is not be the case of the cloud computing. You just have purchased for the 10 minutes time of the predictive analysis software, and the cloud data is available, your data is available on the cloud. You just have to interlink them, and within 5 minutes you can get the predictive analysis of your data. So that is the another benefit of cloud computing. So business continuity, cost saving, performance, virtualized computing, etc. are the some kind of the cloud computing. So cloud computing applications, you can see that everywhere nowadays we are doing the cloud computing services, like all e-commerce platforms are using the cloud computing services. All kind of the AI or the cloud resources, they are also based on the cloud computing services. Online data storage, we are using the cloud service for the online data storage, just like your Facebook, etc. Even I can store my project. If suppose that I have purchase a Google Drive for suppose that I have a 1 TB of the data. So instead of keeping my data always in my laptop, I may purchase a space from the cloud service provider, and I may store my 1 TB of the data in the cloud. So that data can be accessible by myself from anywhere in the world. I can decide who may access my data. So online data storage, backup and the recovery. So I have stored my data in the cloud. So I can take a backup, and suppose that my laptop has crashed, still I can access my data from anywhere. So backup and the recovery is etc. there. Big data analysis. As your data is available in the cloud, so you can apply the some kind of the analysis data analysis software easily. um, you just have to make an interlink between the cloud data and your specialized software, data analysis software, and it can easily generate the predictive analysis. All the e-commerce applications, they are also using the cloud services just like that. If you have a account on the Amazon, so you are just going, you are visiting the Amazon page, and you are ordering. All the informations are available in the Amazon. You do not need to store on your system. Similarly, nowadays we are very much familiar with the cloud computing in education. Just like that, whatever the key players in the online educations, either EDX or up educators, etc., they are providing the cloud computing education. So e-governance applications, governments are now also using the cloud services to store the public information or the governance services in the cloud. Similarly, the healthcare. So your health records are available with the governments, and or do your health records are available in the clouds. And if you wish to show your health record to the particular doctors, medical practitioner, so you can just give the access to them, and that medical doctors can easily see your health record, previous data. Based on that, the health practitioners, the medical practitioners may give you a suitable drugs, etc. Entertainment applications. Now the movie can be accessed from anywhere. So now the cinema halls or the movie theater do not need to purchase the hardware or the reels, whatever happening in the 10 to 20 years ago. Now they can easily connect with their own VSAT, and it can directly show the movies from that particular VSAT. It do not need to purchase the particular set of reels or the information, the movies, and need to play in their uh, theater. Similarly, the social media networks, we have seen a lot of example with the social media networks. Now come to the challenges of the cloud computing. So we have seen the applications of the cloud computing. Now come to the challenges of the cloud computing. So as the cloud is providing a lot of services, so there are certain challenges with the cloud computing. One of the most prominent challenge is the data security and the privacy. Okay, even the Facebook is saying that they will not share the data, they will not share the data with anyone else. So the thing is that you have to rely on the Facebook, that the Facebook may not share the data with anyone else, or the Facebook may told you that the data available, your data available with the Facebook company is very secure, and the Facebook may not sell your information to anyone else. So it means that what you have to rely on the Facebook. If suppose that some attacks are going on the Facebook data, Facebook server, the suppose that your Facebook is providing all kind of the data security and the privacy. But the Facebook may the challenges with the cloud computing. So I don't about the cloud computing. Similarly, the multi-cloud environment, operating with the multi-cloud environment, introducing the various issues, including the configuration mistakes, etc. So, a multi-cloud environment means available with this cloud service provider, few resources available with this cloud service provider, few resources are available with the another cloud service provider. So multi-model cloud service environment, that is one kind of the challenge. Means suppose that nowadays, now you are doing a, now suppose that you are accessing the information, you have lot, you have all the information on your Facebook, and now today you are not happy with the Facebook services, and now you wish to migrate on the some another similar kind of the service provider. So directly you wish to simply move from the Facebook to the there. You have to miss data and only one of the another. Similarly, they cannot directly transfer their data. Similarly, the performance you cannot solve because the from where you have purchased the vehicle, they cannot get it back. They may deny. One of the great. So you have from the Amazon with the Amazon Cloud Service providing services, and after few days you have realized that Amazon is not promptly replying you back, or the Amazon is not solving your fraud, or the move from not available with the cloud service provider until unless they can transfer by themselves. Interoperability and the flexibility is always a great challenge with the cloud service provider. So hidden on the network, in order to access the cloud service provider, you must need to connect with the internet. And that internet also need to be a very powerful internet. You need a high speed internet. So sudden outage or the data is highly vulnerable, etc., are the problem with the always challenge with the cloud service network. Lack of the knowledge and the expertise. If you are unable to know that how to use the Google Docs or how to use the Google Drive facilities, then definitely simply purchasing may not offer you to how to access that one. You need some kind of the expertise, you need some kind of the knowledge in order to use the cloud services. Reliability and the availability is the challenge with the cloud computing. Reliability and the availability, how reliable my cloud service provider are there, and how frequently my data should be available to me. That is the challenge with the cloud service provider. However, mostly the data is available nowadays, but that is always a concern with the cloud service provider. Password security, whatever the Google passwords, Google is saving the password for all, for the every other sites. I- if suppose that you are using the five number of the social media sites, so Google password management saves your all five social media site password pass username and the password. If the Google password is bring all social media user ID and the password with that cyber attackers. So that is the one lost and OPU, all the kind of the hidden. So later on, you will realize that there are some kind of the um, hidden cost may be there. So this is also a challenge. Governance, as the cloud service is being provided by the some private market players, so they have their own set of rule under the privilege. So they may take the advantage of the non-existence of the government terms and condition, and, they are doing like that. Compliance, whenever it can have when it comes to having the some based data compliance policies, cloud service providers are not updating themselves, because in order to update themselves they need a hard is in key happy with to go for the purchase of that one. So again you have to somehow you have to manage with the existing software and hardware, etc. So this is the end of your unit 1. So anyone having any kind of the question, you may just interrupt me, and you may just ask any questions if you have. Okay, let us start with the unit 2. We have some few minutes left, so we can discuss the some portion of the unit 2. So let us start with the unit 2 here. So in the case of the unit 2, our the first discussion is the cloud computing deployment models. So we have a three kind of the cloud service, four kind of the cloud service we have. Four kind of the cloud services we have, or the four types of the cloud are there, cloud computers are there, or four kind of the cloud services are there. Four kind of the cloud providers are there. So the basically the cloud computers can be categorized into the four categories: the public cloud, private cloud, community cloud. Let us see one by one. So access by anyone, by any public, by anyone with their own terms and conditions. If suppose that Facebook is providing service to me, or the Google is providing a free cloud service to me, so anyone, so whatever the rules and regulation is being employed on me, it is basically apply. It is basically apply Google the public cloud service. So anyone can access the public cloud service. So as a of the public cloud, I do not need a heavy investment. I just need a simple laptop through which I may connect with my service provider. No startup cost. Required, because these are the advantages. Whereas the private cloud, so private cloud is under the control of few organization. So suppose that some organization X is there, so X may start their own service and provide the clouds to their public only. So suppose that some organization X is there, so X may start premises of the company X. That will is there, and the company A in terms of the access this source privately. With that, it is better that particular the cloud is being of access easily, and your employee have all your data. So now it's already we are going beyond the time. So now I am stopping today's session here. We may start the discussion uh, from this point forward in the next session. So now this is the time is going up for this session. So if anyone having any question, you may please issue your you may please unmute yourself, and you may please put your doubt here. Alternatively, if you don't have a microphone, you may type your question in the chat box as well. So this is the end of today's session, and I'm just open now. I'm just opening a session for the question answer. If anyone having any kind of question, you may put. Thank you, Yusuf. Nice to know, and thank you, everyone. This is the just our introductory class. From tomorrow, I must expect that you must come with some study materials. You just go through the study materials, come with some concept, and it is better to discuss here. It is not feasible to complete your entire block within 5 session, or the 4 or 5 session. So this is a kind of the counseling session. You should come with what is your to here. That will be the much better. Okay, so I'm not getting any question here. So uh, anyone having? Thank you very much, and thank you very much, Sylvester. And I'm happy to get the question tomorrow. Thank you. Okay, so now it's over. We are running beyond the time. So now, thank you everyone for attending the session. We will meet tomorrow at a scheduled time. Thank you very much.